Alright, so what we're going to be building up to is our unit circle. But before we get to the exact values on a unit circle, we're going to go back over what the 6 trig functions are. And so again, all of these right now are around a 90-degree triangle or a right triangle. So we have triangle ABC, and then we want to make sure we have everything labeled correctly. So the hypotenuse is across from the 90. Adjacent, it's all dependent upon the angle. So if I'm talking about angle A, so we're going to start with doing sine of angle A, cosine of angle A, and tangent of angle A. And then my opposite would be across from angle A, and my adjacent would be the side that shares angle A. So when we talk about the sine, we're talking about opposite length over the hypotenuse. For cosine, it's adjacent length over the hypotenuse. And for tangent, I didn't give myself very much room there, we'll have opposite over adjacent length. And then the other 3 that make it a total of 6 are their inverse functions. So sine has an inverse of cosecant, which is just the reciprocal hypotenuse over opposite. Cosine has the inverse of secant, which is just adjacent over opposite, so it's just the reciprocal as well. And then lastly, tangent has the inverse of cotangent, which will again just reciprocal the ratio, making our total of 6 trig functions. Now if we were to have chosen a different angle, say B, then our opposite and adjacent would have switched, but the ratios are all the same. So what we're going to do is just practice finding sine, cosine, and tangent based on different given information. So for our first example, we're going to be finding all 6 trig functions. And we're given the image. Oops, that's a little off. And we're told this is our theta. We have this is 12, this is 18. So if we're going to find all 6 trig functions of theta, so that would be sine of theta, cosine of theta, tangent of theta, and then cosecant of theta, secant of theta, and cotangent of theta. So if this is what we're trying to find, we have to start by figuring out all the sides. So one of the things I noticed right away is I only know 2 side lengths, not 3. And so I need to somehow find that 3rd side length so that I can do my trig functions. So to find that 3rd side length, because I have a right triangle, we can use the Pythagorean theorem. So I know that a squared plus b squared will equal c squared, and c happens to be my hypotenuse. So if I go through and solve for that missing side length, let's see, I get 324 plus 144 equals c squared. So that would give me 468. So when I square root both sides, I get c is equal to, let's see, when you break that down, it becomes 6 square root 13. So c is going to equal 6 square root 13. So now that I know all 3 sides, it's just a matter of matching up the ratios. So for sine, I'll have my theta here, which means here's my opposite, here's my adjacent, and here's my hypotenuse. And so if you're struggling with telling the difference between your sides, what I do is I start by labeling so that when it comes to just filling them in, I know which ones I'm looking for. So theta is opposite, or sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Oops, 13. Tangent is opposite over adjacent. And so what I'm going to do real quick before I go and do my inverses is if I can simplify these, I'm going to. And so if I simplify these, one of the first things I can do is rationalize, which means we multiply top and bottom by root 13. And I also notice that I can simplify my numbers. So I'll be left with 2 root 13 on top over 13 on the bottom. So when I go to do my reciprocal for cosecant, I can put root 13 on top and 2 on the bottom. So I can do my reciprocal based on my 2 over root 13 here. For cosine, again, I can simplify here and make it 3 over root 13. So that would give me a secant of root 13 over 3. And then I just need to rationalize here, which would give me 3 root 13 over 13. And then for tangent, it's all numbers. We don't have any square roots, so we can just simplify. So 6 goes into there twice, so 2/3, meaning our cotangent will be 3/2. So again, all we did here after we set up the ratios was simplify and rationalize, and then before rationalizing you can do your reciprocal, because your reciprocal is obviously not going to have that square root in the bottom anymore. So you are going to have some on your assignment that are missing just one side, so where you have to use the Pythagorean theorem and then go and find your 6 trig functions. Another way that you're going to be given information besides a picture like this is going to be in a form of a trig function. So if we're given the cosecant of theta is 10 over 6, and we need to find the remaining 5. And I didn't spell remaining right. So this one, we're not given the picture like we were in the first example. We are just given a ratio, a trig ratio. So what you want to do for this is draw the picture and label what you know. So I'm going to draw my own right triangle, because right now we're just dealing with right triangles. And I'm going to label my theta. I can label it however I want, because this is my picture. From my theta, I know across is my opposite, next to it is my adjacent, and then across from 90 is my hypotenuse. So, looking at the trig function that we were given. So we were given the cosecant. So cosecant, if we remember, is hypotenuse over opposite. So that means this is my hypotenuse and this is my opposite. So I can use what I know about the ratio to label the sides that on my triangle. So 10 is going to be my hypotenuse, my opposite is going to be 6. So now I do have a right triangle where I know 2 sides and I'm missing the third. So I can use Pythagorean theorem to help me find that third side. So 10 squared is my hypotenuse, so 10 squared equals 6 squared plus my adjacent squared, so I'll call that A. So 100 equals 36 plus A squared. Subtract 36 from both sides, and we end up with 64 equals A squared, which means my third side would be 8 after I square root both sides. So if I'm going to go next to find my remaining trig functions, I can find my sine of theta is 6 over 10, which I can reduce to 3 over 5. My cosine of theta would be adjacent, so that's 8 over 10, which reduces to 4 over 5. Tangent theta would be my opposite over adjacent, which reduces to 3 over 4. Cosecant we were given in our original statement, but we can reduce it, so I'm going to reduce it to 5 over 3. The secant theta would be 5 over 4, so I'm just going to use my already reduced version. And my cotangent theta would be 4 over 3. So that would be the one you had plus the remaining 5. So the two ways you're going to be given information about your trig functions the most are either giving you the picture with maybe a side missing, or it's going to give you a trig function and you're going to draw your own picture and find the missing side, again using Pythagorean theorem. Okay, there's one other way that you're going to have information presented to you and be asked the same thing: find your 6 trig functions. And this next way, you do have it on your test, and I'm not sure if you've seen it before in Math 3 or not. So if this is the one that you have questions on, please be sure you ask. So this is our number 3. Star it or mark it or something, because you do have one like this on your test. And here it's going to give us the point on the terminal side of an angle in standard position. Is -3, 4. Find the 6 trig functions. So here it's giving it to us in terms of where it is on a coordinate graph. So again, one of the first things you want to do is draw it, because we can do things a lot better when we can see it. So I'm going to draw my XY axis, and I'm going to plot the point -3, 4. 1, 2, 3, 1, 2, 3, 4, -3, 4. That's the point on the terminal side. So that means my terminal side is right there. So I have this angle in standard position, meaning it starts here and goes all the way here. So when we look at this, I'm going to make, right now this is an obtuse triangle. We don't know how to do that yet. So what we're going to do instead is stick with the right triangles by drawing the vertical line, sorry, that should be hitting at 3, and making a right triangle, with theta being its reference angle. So last year I know you guys learned about reference angles. They're the acute angles that are equivalent. And so if we look at this standard angle, it's going to have equivalent trig functions as an obtuse angle to this acute one. So what we want to do is draw the right triangle, knowing that this is -3, 4. And if we think about what that point means, that point means that the distance of this side is -3, because we went -3 on the x direction, and the length of this side is up 4, so we went up 4. This is telling us what two sides of our triangle are. So using Pythagorean theorem, we can find the missing side. So I can again use my Pythagorean theorem to find my hypotenuse. And so that will give us 9 plus 16 equals h squared. So 25 equals h squared, meaning my hypotenuse is 5. So all of these today have had, or tonight have had the same information in the end. It's just how we go about filling it in is a little different. So we could be given the picture with two sides and one missing. We could be told a trig function where we have to draw our own picture and label it based on the information given. Here's one in terms of a coordinate system where we have to understand that the length of this side is from 0 to -3, so -3. And then our vertical distance, 4, and then using Pythagorean theorem to find the missing side. Once you have all your sides, we can fill in our information just by reading off the sides. So sine of theta would equal opposite over hypotenuse. Cosine of theta will equal adjacent over hypotenuse. Tangent of theta would equal opposite over adjacent. And then their reciprocals. So cosecant theta would equal 5 over 4. Secant theta will equal 5 over -3. And cotangent of theta would equal -3 over 4. So it's, again, more about the way the information is given to us that's going to change, but the process of how we do each one remains the same. So tomorrow in class, if this is the part that's still a little confusing, let me know and we can go over another one like it. We're also going to be working next on our exact values and our unit circle. And so be prepared for that in class. We'll do that as well as the assignment for this.